So if I could have you guys, could I have your attention here? So we have, we're creating this negative or positive linear relationship table. Who did a positive one, just by show of hands? Whoa, we got some kids challenging. Hands down. Who did a negative? Nice. All right. So, okay. Does someone want to share their positive relationship that they did?
No.
Okay. Cody, go for it.
I did dollars per snack.
So dollars per snack. So describe it.
So I did for $0 you can get one snack, and then for one you can get two. So you get a free snack.
So here's my thing.
You just have to watch by the...
Not sure if that's real life, but it's kind of stretching a real life situation. Could it happen? Yes. Does it happen? No.
Or does it?
No, actually, you know what? I take that back. Sometimes when you'll go to like events, they'll give you a snack for free, but then they might charge you for the next one. So okay.
But then free samples like at Costco and stuff.
Oh yeah.
Okay. A negative relationship. Hold on, I got the positive. Negative, Ryan.
So I kind of did like the amount of items and like the amount of money. So I said that like at 0 items you have $10, and then I just went for the items I just went up by ones, and for the money I just went down by 2. So like every item is $2 kind of.
You're at the dollar store. The $2 store. I'm at the $2 store buying some $2 junk. Why go to $2 store when you have the dollar store? So, how much did Ryan start with? $10. How many items will she be able to buy before she's broke? 5. How many items can she buy to go in debt? As many, as long as it's over 5. 6 or greater, right? And then she's in debt. Don't do it, Ryan. Okay. Retakes.
Somebody threw something in the
Just retakes tomorrow morning and Wednesday morning. I've updated grades. I've updated grades in Infinite Campus, and then we have Friday schools happening this week. So we're back. I can statement. This is day 2. So it's basically I can determine how the pattern of change appears in a graph, table, and equation. What did I ask you to do here?
Make sure you explain.
No, but as for the I can, in this I can, what did you have to do here? Ryan?
Create a negative or positive linear relationship.
Which means it has to have a pattern of change. So we're going to not only have you just created one, but now you're going to have to identify and determine the pattern of change. And today we're really going to be looking at the tables. Any questions?
No.
Okay. I have over there is Josh. Who is? And it was supposed to be Ashton. It was Chris. It was supposed to be, yeah. No. So, Josh is going to go ahead and he's going to explain.
Something.
It's going to be good.
Josh, by the way, you only said it.
Okay. Grab your homework. If you didn't do your homework, stay at your desk. And
I did it because I was.
A is wrong.
That's
Josh.
the point.
A is wrong.
Okay, why is A wrong?
Because A is linear because you're on the X column or whatever. It goes up by 10 every time. And on the Y,
It's going up by constant rate. It's going up by constant rate.
Yeah. Well, there goes my serious. I have no idea. But with B, I got it wasn't consistent because
It's a linear relationship.
it is. It's not.
Yes.
B isn't.
Yes, B is.
How?
Because
What's it?
it's It tries to trick you. But when I did it, I got
So, but then it asked you guys, didn't it ask you to write an equation? Look.
Then I got 2 on every one, so it's a linear relationship.
She's got this part.
What?
Jay, is it be a linear relationship?
See, so it's 2, 4, 6.
Yes, no, no. Yes.
It says,
Yes.
suppose each of the following patterns continue. Here are your patterns.
I can't see.
Which represents the linear relationship? And then it says explain. Doing yes, no's. Come on, it says explain. Did you explain?
No.
Okay, good.
Okay, wait.
Then it says,
A minute.
Then it says, for those that are linear, write an equation. There are 2 parts.
Okay, so what happened? I got B wasn't linear because if you look at it, what Jaden said she got is it went up by 2 each time, but
You can look up there. Talk about B.
So it goes by a gap of 8, and that would only be 4. That would only be 4, but
This side's going up by 2. This side's going up by something else.
see, look, that's
is a
going
linear
up by a
All right,
different
let's
one.
do this.
But
So we're having a good discussion about B. Changing Y, changing X. So look over there on B. Let's do the first of X. We go 1 to 5. What's that change?
5.
1 to 5?
4.
Okay. And then the X is 9 to 17. What's that change?
8.
Bravo, Shaggy.
I was wrong.
All right, that's okay. That's why we're doing this. I love it, Josh, that you're up here. Okay? So, but wait. Does that mean the whole table is a change of 2?
No.
No, so check again. Go to 20 and 21. What's that change?
1.
1. Okay, so we have a change of 1. And then go to the Y. It's 47 to 49. So what is it? 2. All right. So we're looking pretty good on that one. So Josh, ready? I want you to use the change in Y over change in X.
Okay, here, may I please see the marker?
Yeah, you got it, my man.
Okay.
Hey, more questions.
Okay.
If it's linear, you need to write an equation.
The next 2 are right.
Who got C was linear?
Not me.
See, how did you get C was linear?
Well, if you look at C, you just multiply X times 2, and then that gives you Y.
See, but that's not what linear is going up at a consistent.
linear.
It's not. No, it's not. It's not linear.
Hey, linear would be going up at a consistent rate. And it's not going up at a consistent rate, so that means it's not linear.
It's X times X, which is X times X.
Don't kill me. Yes!
So, hey,
I dropped my pencil.
I want you to go back to B. Get the equation down. Come on, work together.
Oh, yeah. Where'd my marker? Oh, I have it.
This marker's going out.
I had a marker in my hand, and I was like, where did I put the marker? Yes. 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 No. No. What happened to my D?
C, D. There we go.
All right, guys, hey.
Did anyone get that?
Yes, no. So,
Did anyone get that D was linear? Okay, we're all good there.
okay, let's go. Let's get equations for A and B.
Okay,
Help them out.
so I need the chair back. As soon as okay.
X times 3 plus 1.
Okay, so for A.
Josh is so tall.
Okay, so yeah, you know, the change in Y would be 30. Don't turn it off.
I didn't.
Mr. Mick, this marker's out. Can I throw it away?
Use this one.
Mr. Mick,
No, I want it.
give me it. The change in Y is 30.
Okay.
And the change in X is 10. I didn't almost fall off the chair. And in B, the change in
Because what's he doing? He's just looking at the change.
Oh my God.
Josh. Yes, I did. I forgot that I couldn't walk, so I went to take a step. Okay, Josh, I'll just stand right here. Josh.
I know that's what you got.
Welcome back to the ASMR channel.
Ben?
I am.
Time, Ben. Just so you know.
Sorry.
No, it's okay. It's not my time. You don't have to apologize to me. It's your time. Why apologize to me?
What is the equation for
Josh,
B?
you guys
It's
are
never
done.
been put
Ben,
here.
you're done. You can go sit down. I don't need your help anymore. Thank you. You're not being very productive. All right. All right, guys.
It's not following you.
We are out of time, so I need you guys at... All right. All right, so we're going to do one of these together. Since neither group got to this, the second part, guys, I want to bring your attention to like reading directions. Because if you're only going to do part of it and you know, like I know all of you know how to read. Like I know that. Now, if you only do part one, you know how to read. So you're just not doing it. It's not like, oh, I missed it. No, you're not reading. So we might have to think of something different if this is how this is going to go. The reason why is I need you to do all of it, to try all of it. Not just the part you want to do or the part you'd like to do, but do all parts. Because then it makes our discussions so much better. And if it becomes a time, Ben, you want to listen. If it becomes a time where it's an opportunity for you to get people off task, I will find something different for you during your time. I want to keep doing this because I feel like it's beneficial. But it's only beneficial if each and every one of you take it serious to a certain extent. I'm not saying you have to go up there and be like all militant and stuff like that, but you do have to take it serious. This is math class. It's not a free-for-all. So Allie, I get it. People say funny things. But that does not mean we continue with it. And I'm not saying you are to blame. But I do think we all can do a better job than what we did today. I feel like that 5 minutes is a good opportunity for you guys to have conversations, but maybe we change it. So it says, for those that are linear, write an equation. So we found out that this is linear and this is linear because change in y over change in x. If I find points here, I have a change in 30 in each one. So that's my change in y. Here, change in 10, change in 10, change in 10. So I have a change in y over change in 10, which is the change in y over change in x. So I get a rate of 3. That is my unit rate. So now, talk to your tables. How and what do I write for my equation? Go. You guys good? Chris, you guys good? Okay. So here's our standard equation. Y equals mx plus b. We use this all the time for linear functions. So, what's my m stand for? Chris, my rate. What was my rate that I just figured out? 3. So I substitute 3 in. So now I have y equals 3 times x, because x and y are not going to change. Those are my independent and dependent variables. And then I have plus, and then this b. What does that b represent, Anthony? That's the y-intercept. Now, where is the y-intercept in my equation here? When the x is at 0, what is the dependent variable at? This is 1, so it's plus 1. That would be the equation for that linear relationship. We have 1 minute. Well, let's give a minute and a half. I want you to figure out this one, because we all said it's linear. Okay? So go ahead, talk your tables. Go.
You need to find I know. 1492.
So what'd you get? What'd you get? No, for your equation.
No, but C is not linear because it's 9 for every one. So for the first one, sorry, the 1, 4, 9. But for the y-axis, look, it would go like this. It has to go up, 1, 1, and then 4.
Figure out. All right. Let's come back to that here. So Rachel, let's do change of y over change in x. What's my change? 4. What's my change?
8.
Okay, what's 8 divided by 4? Okay, so we have a rate of 2 here. Does that mean the whole table has a rate of 2? No, we got to check 3 spots, because it is not proportional. Here, change in 1, change in 2. What's 2 divided by 1? 2. And then again here, we have a change in 13. Here, 26. 26 divided by 13. So what does that mean? It is linear. So then I'm going to go to Presley. Presley, we're going to use this y equals mx plus b, knowing that x and y are going to change because that's our independent and that's our dependent. So tell me what would be my equation.
We said y equals x times y equals 2.
X times 2? Okay, that works. Usually it's the other way around, but keep going. Plus. Okay, how did you get 7?
Well, like if you do 1 times 2, you get 2, and then you add 7 and you get 9. And if you repeat that for each of the numbers, you get 17.
So she looks up here, she says, wait a minute, 0 isn't on here, is it? No. So she puts 0 above. She says, I have a rate of 2 for every 1. So instead of adding 2, I subtract 2 and I get 7. Okay, today, I wanted to go over that because that's such a big part of what we're doing today with our I can statement about determining the pattern of change. Today, I'm going to have you start. We're not going to work for very long, but whoops. I want you to start on A4, A4A, go to A5A and B. If you've already done those, then you'll be down here on the B1 and B2s. Do this on the back of 2.3. You grabbed it at the door. It is on page 34. It's your turn again.
It's never been anybody else.
What are you talking about? Is that for them? No, the fog group I don't do.
The what?
That's for me to worry about, not you.
Hi.
What are you guys on? What question are you guys on?
I don't.
There we go, my hair's fixed. I swear, whoever cracked this must be really heavy.
Go get that.
Oh, I'm on A5C.
Come on, get your book out.
Oh, never mind. I'm on B1.
Oh. I'm on B1 too.
Fill it in.
We're already starting.
My God. There.
Yeah.
That's it.
Yeah, most of
Okay. We have to talk about it, I guess.
This company has a Y-intercept or starting fee of $34.
Wait, how can we compare the cost for this company?
He said do it on the back of 2.3.
Compare the cost for this company to the cost for the two companies. Oh, okay. So,
See on the homework. It's not linear, right? Because if one would be 24,
Exponential.
equals 4, then yes, I'm a horrible person. We already did this. Are you sure?
Watch this. This is so funny.
We did this on Thursday. Yeah, we did. Yeah, we did questions. All right.
Ashton, look at my hair right now.
No, we're not.
It goes right back to the same spot. Want to bet? Okay, don't touch it.
What do you guys think the rate is?
I think the rate is
I don't think they're on this problem.
I think he is, but I don't think you are.
I know.
I had just gotten to A4.
Okay, then you're still doing it. You're doing A4A.
I know, that's what I'm doing right now. What are you guys doing?
B1.
B1. Oh, you should have seen Brady's hair in Vanity. He had one hair that was sticking straight up. I mean, it wasn't one, it was like a ton.
Do your work. Stop staring at Ashton.
Where's the microphone on this thing?
It doesn't matter. So, the change in Y was 7.5 from 35 to 41.5, and then the change in X is 3. So
How do you know that?
for I usually go 3 minus 0 is 3, and 41.5 minus 34 is 7.5. That's the starting rate.
So you have a change in Y, which is your C, right? Change in X is your N.
Yes.
Make sure to write them down. Don't just do the math in your head. You know what I mean? Like what I did. Like I could write down I could do 4 divided by 2 in my head, but I still write it down. Okay?
Hey, there's a pencil in here.
What was the change? Probably
7.5 and then wait, no. Yeah, that's what I meant.
It changes everything. No, we didn't do it. What do you want? How many books do you read?
Me?
Yeah. I swear, you come to class every day with a different book.
This is unimportant. That's because I finish the books every day.
Wait, so you guys are comparing them using that equation?
I'm using the rate. I'm trying to find out the rate, and that's where I got the change in y over change in x.
There's 2 different types of so, CJ, focus. No, you're not.
I got a rate of 2.5.
Wait, so then does that mean I said where the y-intercept started? Is that a way to compare it? No. Does that count for this problem?
The it has a different y-intercept from the other two, so yes, and the rates are different, I'm guessing, which they are.
But so would this work?
Yeah.
Yeah.
Oh no, I just remembered. I was on E5, the last part of E5.
Where's your binder?
It's gone.
So if I make a table for my shirt,
Everybody's looking at me like I'm stupid.
In this time so what's the pattern of change between the two variables?
Is the relationship between what?
I would say yes, it is linear because it has a constant rate. It's pretty much asking, is this linear? And if it is, what is the constant rate? And I'm saying,
But
yes, it
really
is.
a constant rate, is there?
Yeah,
I can't see. I just looked at it, so I can't really tell.
Yes, it is linear because it has a constant rate of 2 5/10.
2 5/10.
Yes.
Then how do you get from 56.5 to 454? Which problem are you on?
B2.
Yeah. So you're using the t-shirt costs table, right?
Okay. So would the point 2084 lie on the graph of this cost plan? Well, so what's 20 times 2.5?
Well, 20, there's a 10, so 59 times 2, whatever that equals.
50. Wait, what?
Never mind. No, it would not.
20 times 2.5?
Wait, maybe.
173450568.
1 second. I'm just...
Explain what the relationship between the cost and the number of... No, it's on In each equation, what is the pattern of change between the two variables?
I don't think it is.
This point? No, it wouldn't.
Mighty no shrink.
I'm waiting. I know, but okay, but hold on. What you have is doesn't make sense because I don't know.
For mighty T, C no shrink is the cost of dollars. For no T, no shrink.
Sure, no one has 0, 0. Or no. No shrink has 0, 0. But then mighty does not. Mighty starts at 49. You have 54.
I drew a perfect V.
Oh wait, there's the 49. Oh, and this is the number of shirts. Ah, got it. I got it. You got a big label. So put up here, column heading shirts. That would be.
What information about the number of t-shirts and cost do the coordinates of this point represent?
What? Huh? I'm still writing 3A.
Oh, sorry. CJ, are you doing any work?
Yes. And I was reading. And
well, we're working it through with you. So how about
How about you just work on these ones with us right now, and you can go back and do this.
And then I'll do this one then. Okay, that makes sense. I'm just going. Wait, what problem are you guys on?
Right now we're on
B3B.
B.
Okay, I'll start on B1 then. Or should I just start on B3?
Yeah. I'll probably start with
Okay, I'm on B3.
So, CJ, looking at this graph with the point 20 and 84, like with the coordinate 20, 84, be on this. So, like, what is 20 times 2.5? Because 2.5 is 30, right?
Yeah.
So, at 20 t-shirts, how much would it be? Would it be $84?
Yes, it would. There, when you add the y-intercept, it would. 50 plus 34 is 84.
Yes, that's right. Actually.
See, I was going to say 50, but then I was like 2.5. That didn't make any sense.
2.5 times 20 equals 50 plus 34 equals 84.
Yeah, I know. Wait, so that was B3B.
No, that was B3A.
Okay, good. Yes. Oh, shoot. I wrote it on the wrong one.
Josh. Chris.
Well, actually, reading the next problem gives it away.
That's why I'm so confused. I was like, what?
Yes, because...
Point 2084 represent that when you sell 20 t-shirts, you would receive $84.
It will.
Dude, like, it costs more to shop at the No Frame after like 15 shirts. No.
Wait, so is this just the equation?
Wait, yeah. Why are you going so high?
Huh?
It's probably
Oh, yeah.
like 25. What the heck are you guys doing? What? I just wrote that one.
The equation would be cost equals n
Times 2.5
plus 30. B3D, 2080 would not be a solution because 2084 and 2080 can't be on the same graph.
Yeah, because 20 and 20.
That's logic.
But 14 and 69?
I don't know.
No. Yeah? Wait, because right on the number it's 3. Okay, well it's 4 times 2.5. Is it 4 times 2.5?
I'm trying.
I think it's 10, and then if it's 10, it is.
What did I miss? Sorry.
Because 10 plus 14. I think it is.
Would be from that long total.
Yeah, so it is.
What did I miss? Did I miss anything good? Did I miss anything bad?
Wait, no, it's still 14. Guys,
Wait, what's N? N's the amount of t-shirts, right?
Yes.
Okay.
Where'd you guys get your 5.25 from?
5 point.
What?
I don't have a 5.25.
Do you have a 2.5?
Yeah.
Yes. Yeah. That's where I am.
All right, guys, please pick up. Okay, because that should be, it's a rate of 2 points. Okay, as you are picking up, return any books that you might have used. And then, Ben. Okay, then on the board. So we're talking about, hey guys, we're talking about determining the pattern of change. And one of the things that I noticed from last week is that I think we're getting better at this, but I really wanted to challenge you today. So, I gave you some scaffolding, change in y over change in x. We know that we need to use this at least 3 times in a table to figure out if it truly is linear. Jane's like, yeah, I've got this. We have table 1, 2, 3, and 4. Please tell me which tables are linear. Okay? Remember to check at least 3 spots in the table. This is table 1. Table 2, 3, 4. And on your paper, you're going to want to say table 1's linear because, or table 1 is not linear because. So you want to basically just describe that in a sentence. You can tell me the unit rate if it is linear. Change in y over change in x. Cody, you need to be writing. Come on. -4 to -2. What kind of change is it? +2. Okay. So here I have a +2 change. -10 to -8. +2. So I have a change of 1. So here, +2. Here, +2. Here, +2. Here, +2. So I have a 2 over 2 change on each one of these. My unit rate's a 1. Is it linear? So go ahead and do number 2 and number 3. Number 4. Remember, you got to check it in 3 spots. Ben. No?
How could it go from +16 to
Is it linear?
Tables
No, it's not even. It's not even proportional because in order to be proportional, it must be
Linear.
It goes through 0, 0, but that doesn't mean it's proportional. Yeah, all you got to do. Remember, if it's not linear, I'm going to know once I do one check of change over y, change over x, and I do another one, and those rates don't equal. What does that tell you?
It's not linear.
Not linear. You're done. Move on. And you just say, yeah, it's not linear because it has a different rate.
Not linear.
Ben, you need to write these down. Tired, Radonna? Come on, Josh, keep going. Don't ruin it for him, Radonna. So this really matches our I can statement about determining that pattern of change. If we have a rate, we have a pattern of change. If it's proportional, it's pretty easy to see.
Yeah.
So which is the easiest one to see that it's linear?
3.
Number 3, because it's proportional. It goes through 0, 0. When something goes through 0, 0 and it's linear, you see the pattern really quickly. You're like, oh, there it is. I see it.
Yes, it is. He just said it was linear. I read it wrong, okay, Josh? Okay.
You guys are arguing each other today. Man, you guys are like two brothers.
No, that is bad. Trust me.
Brothers from another mother.
No.
My brother's from the same mother.
That's not how brothers. My brothers from the same mother.
So let's look at y, because y doesn't stick out very easy. What do I have over here for a change?
2.
Positive 2. What do I have here for change?
2.
So then I can look. Wow, that's easy there. There's 2. There's 2. So far I have a change of 2 over 2, which is a unit rate of, and then 2 and 2. So table 1, linear. Table 3, linear. And table 4, linear. But it's all about, guys, it's all about establishing that pattern of change, that unit rate. Can you find it? If you can in a table, then you know it will be linear. Good work. Thank you, guys. Homework, yes, 6A, B, C, and O. Don't you forget.